Alright, this is a Bahtinov mask pattern. Specifically, it is 1/3 of a Tri-Bahtinov mask that I have designed for my Meade LX200 12-inch aperture telescope. And using the donut method, it looks like it's pretty well in collimation, but I wanted to make sure of that, so I have designed and 3D printed this Tri-Bahtinov mask, which will fit over the end of the central obstruction. So the idea with the Tri-Bahtinov is that each of these diffraction patterns is going to line up with one of the 3 adjustment screws for collimation. And so if any of those are out of whack, I can use it to kind of get it into collimation perfectly. It's also useful for focusing when I'm done with collimation, although I might just make a single Bahtinov mask that will go at the end of my AstroZap dew shield. So for collimation, I think I'm going to have to take the dew shield off and put this on so I have easy access to those 3 adjustment screws. But just for focusing, I want something I can hang on the end there and just use that for focusing. And so the idea is that I'll glue 3 of these together and it will fit perfectly around the center occlusion, so I can just kind of slide it down over the center occlusion to mount it at the end of the optical tube. Alright, this is a dry fit of these 2 pieces. I'm using a straight edge down here to kind of basically get this thing connected correctly that way, because there's no dots or anything that basically will line this up and get these things lined up. And I do need this slot to kind of line up here, because there's a screw head that's going to go in one of these 3 slots as kind of an alignment thing. It just happens to be on the outside of the ring of my center obstruction in my particular telescope. And so I have this side weighted down with a pretty heavy battery, and I'm basically ready just to take this guy and slide it in there. And then I have this ridge here split in half, so I just clamp that to hold it while it glue sets. So I have this big AstroZap dew shield over the end of my Meade telescope here. So I have to kind of reach in to pull this thing on and off. So if you didn't have this big black dew shield, it'd be real easy to install. You basically just put this guy down over the central obstruction, and there's these slots here, and there's a screw right there. That slot sits over, and that keeps this guy from rotating. So it goes on, and it maybe will go a degree left and right type of thing, but it basically stays in that orientation. And so now we have the Tri-Bahtinov mask over the aperture. Now the design file is parametric, so as long as you have a cylindrical center obstruction that you can put something over, all you have to do is change the numbers to make that circle bigger or smaller. Now, if you have more than 3 screws at 120 degrees, I actually just have 1 screw on the side, but if you have more than 1 screw, or the screws are not at nice 120 degree angles, you might have to adjust the code to make those little notches in different locations. Of course, if you don't have a 12-inch, you can change the number for the outside diameter, and this thing will get smaller or bigger if you have a big enough printer to print it. Now, this is not a structural part, so super glue holds that thing together just fine. I'm probably going to hit each of these lines here, the join lines, with a soldering iron, just to kind of melt the outside edges together. It won't look quite as clean when I'm done, but it'll be slightly stronger. So I have my plastic welding soldering iron on my soldering iron. This is used only for welding plastic. My soldering iron is set to 480 degrees centigrade, and this is the seam that's just super glued together here. And so I am going to hit that with this soldering iron and just follow the seam along. And the nice thing about this is the soldering iron pretty much just follows that seam, because I kind of have a V blade in there. And so when you get done, it's not perfectly even, but it mostly follows that line. And so it looks pretty reasonable. It's not going to look obviously horribly icky and wrong. And it definitely seals together those 2 pieces of plastic. So I'm just going to do that on the other 3 sides here. So if you're following a straight line, this can be a very quick procedure. Now on the bottom, if you have a seam on the bottom, the only danger was when you do this, it is going to make a V groove that goes down a little bit, which probably isn't going to matter in most cases, but that's just something to keep in mind. So you'll see some super glue stuck in the bottom there. Alright, so a bottom groove, when it's done, looks like that. So this here, I think, looks a little better than the crack. There's a groove, but it's kind of a smeared together groove, so there's not an obvious crack, with the possible exception of right here. I don't think I kind of got it quite hot enough there. So up here and below it, it's smeared, but there's a little crack right there. So on the back side, the groove definitely goes in, so it's an indentation, and that's, you know, pretty obvious when you look at it. But I think it's a much better seam than just the super glue. Now there's still super glue holding it together in the centers, but on the top and bottom edge, that plastic is melted together. And I also, you know, did these end pieces, and I did the little vertical seams inside of there. So melting ABS plastic is typically an outdoor activity, but you might hear all these fans I have going on in here, so I recommend you do it outdoors unless you have some good exhaust and filtering fans.